All right, let's get into solving these two integrals. So first off, this integral right here, you're going to see is actually pretty easy to go through. And then this integral, it's not too bad too, but it's a little bit convoluted, so let's talk about it. First one, we're looking at this integral. Now the way we handle this one is, this is basically the integral, and we're going to have the x minus 1, but the easiest thing to do is to take this term and write that as x to the 1/2 power. And now I'm going to distribute that in. Now remember, the first one there, that's x to the first power. So now I have the integral of x. When I distribute that in, you got to add the exponents. So that's going to be to the 3/2 power minus x to the 1/2 power dx. Now I'm just going to follow the rule. This becomes x. I have to add 1 to that, which is going to make that 5/2 over 5/2 minus. Now it's going to be x, and I have to add 1 to that, so that's going to be 3/2, and that's over 3/2. And then I have to add a constant. So now when I just fix this up a little bit, this becomes 2/5 x to the 5/2 minus 2/3 x to the 3/2 plus constant. First part, done. And now for the more complicated integral. So here's what we have. Let's do a U-substitution where we're going to let u be equal to x minus 1. And if we differentiate both sides, we can write this, du is just equal to dx. But then also make a note here, if you add 1 to both sides, you get u plus 1 is equal to x. Now I'm ready for my substitution, so here we go. Integral. Now notice, x is just going to become u plus 1. And then I have the square root, and then I have x minus 1, but that's what my u is actually, so I'm going to plug that in as just u. Since du and dx are equal, that's just going to be du. So now I rewrite. I have the integral u plus 1 times u to the 1/2 du. Distribute. And then use the power rule. And now just reduce it. And finally just substitute what u was. Now don't forget, u is just x minus 1. Now I'm going to substitute that back in, and I have this. Done.